Hi everyone, my name is Neha Kardam, and in this lecture we are going to learn about arithmetic circuit. This lecture is the first part of arithmetic circuits, and there are other three more parts which we'll be seeing in the next coming lectures. So let's get started. So in this lecture we will learn about binary addition, half and full adders. And in the second lecture we will be learning about binary subtraction, half and full subtractors. And in the third part we'll learn about parallel adders and subtractors, application, using adders for subtraction, and in the fourth part we will learn about the multipliers and 2's complement. So let's start with the binary addition. So binary addition is similar to the decimal addition. Let's take an example to understand the binary addition. So we have this this binary number 1010 and 11. So we have to add these two numbers. 1010 is basically 10 in decimal, and 11 is 13 in decimal. 3 in decimal. So in total, if we add them up, it should produce 13. Okay, so let's add them up. So 0 plus 1 is 1, 1 plus 1 is 2 in decimal, and in binary it is 10. So 0 is going to come here and 1 will go here as a carry, and then 1 will come here, and then this 1 will come here. So now you have 1101. And if you convert this binary number into decimal, then this will come out to be 13. So let's see some quiz question to understand this binary numbers. Now we have this example to add 11010 and 1100. So we have to add these. So if you add 00, it will come out to be 0. 0 plus 1 is 1. 1 plus 0 is 1, and then 1 plus 1 is 2 in decimal, and in binary it is 10. So 0 is going to come here, and then 1 will be carry, and 1 plus 1 is again 10. So 0 is going to be here, and then you have 1 here as a carry which will come here. So now this is the addition of two binary numbers, and that's how you do it. And if you have a carry, then that goes to the left side, similar to what you do in decimal addition. And it's just that you have to keep in mind, if you have 1 plus 1, you don't write 2 in decimal here because this is binary. So you have to keep in mind, in binary it is 10, and based on that you do the computation. Now let's see the half adder. So the logic device that adds two binary numbers is called your half adder, and half adder adds least significant digit columns in the binary addition. Let's see the block diagram of half adder. This is the block diagram. A and B are the inputs going into the half adder, and this basically represents your sum, and this C0 is your carry out, which represents your carry. Now how this is the block diagram. So how the circuit looks like for the half adder, we're gonna see here. So this is the half adder circuit. We use the XOR gate to add two numbers, and then we send the these two inputs through the AND gate to form the carry. Okay, so if you calculate what would be the sum for the XOR gate based on these two inputs, so it will be A XOR B, or you can say A B bar plus A bar B. Okay, and then output of the carry out is going to be AB. Okay, so and then you can form the truth table also based on this, and where A and B, these are two inputs, so it will have like 4 different combinations, and then you can add the sum, and sum will be basically goes here, and then carry out is going to be here. So we are going to see that next. Now here you see the truth table for half adder. B and A are the inputs, and these are the 4 different combinations we can have. And then this sum, this represents your sum, and this C0 is the carry out. So if you add these 2 bits, then this is the sum which is going to comes up. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is the sum is 0 and the carry is 1, and that's why you have 1 carry here, and for rest of the above places you do not have any carry. And for sum you have a XOR gate, and for carry out you make the AND gate. And this thing you can figure it out from this expression also. So wherever you have ones, look for that. So we have 1 here, and if we see corresponding to this, we have B bar A. Okay, and then we have another one here which has B bar, which has B and A bar. So B bar A plus B A bar, that is your XOR, which is your sum. And then the carry you see here, this is 1 is here, and then corresponding to that you have B and A. So that's why you use AND gate, which is equals to BA. Okay, now let's move on to the quiz. This is called a half adder. This is the same circuit which we saw in the previous slide. Half adder, and then what are the sum and carry out outputs from the half adder circuit if you have 0 0? So if we have 0 0, we know that the sum is going to be 0 and carry out is going to be 0 2. What are the sum and carry out outputs from the half adder circuit? If you have A0 and B1, if you add them up, you will have sum 1 and carry out 0. So that's why you have sum 1 and carry out 0. Now what are the sum and carry out outputs from the half adder circuit? So if you have 1 1, then sum is going to be 0 and then carry out is going to be 1. And you can also try putting the values here and then see if that's the same value is coming out here or not. So if you have 1 1 going into the AND gate, then your carry out is going to be 1. And if you have 1 1 going into the XOR gate, and for the XOR gate, if you give 1 1, then output is going to be 0. So sum is 0, carry out is 1. Now what are the sum and carry out when you have A1 and B0? So again, the sum is going to be 1 and carry out is going to be 0. Now let's see the full adder. So the full adder can be made from 2 half adders. This is the block diagram of the full adder. These are the 2 inputs going into the full adder, and this scene is also this is called your carry in, which goes into the full adder, and then you have a sum, and then you have a carry out similar to half adder. We will see the logic diagram, and this logic diagram shows like how it is made up from a 2 half adders. If you notice the block diagram, then let's see first this one. This has A and B input, and then this is the sum going into the next half adder, and this is the carry out which is going into the directly to the OR gate. And then this half adder has input C in, which is carry in coming in, and then the output, which is the sum of the first adder, is first half adder is going into the B. And then you have a sum coming in here, and then carry out goes into the this carry out. Okay, so this carry out basically takes the sum of first and the second carry out of the two half adders. Okay, now let's see the truth table. These are the inputs. C in is the carry in, and B and A are another inputs, and these 3 together makes up these 8 combinations. So you have all these zeros, 4 zeros, 4 ones, and then 2 zeros, 2 ones, and then 0 1, and so on. Now if you add them up, you will have some sum and then some carry. So all these are zeros, so you have sum is 0 and then carry is going to be 0. When you have 2 zeros 1, and so this is going to make 1 0, and then if you have 0 1 0, then 1 0, and then now we have 2 ones here, so now comes the role of the carry. So the sum is going to be 0 and carry is going to be 1, and then here it's going to be same 1 0. In this one it's going to have the carry, so 0 and 1, and then this one is again 0 and 1, and then here you have 3 ones. Okay, so when you have 3 ones, then you will have some carry 1 here, and then some sum which is here 1. So this is a full adder, and if you want to verify the truth table, you can put all these values into this circuit and see what comes out. And also you can design the circuit for this full adder just looking at the truth table. So as I mentioned earlier, like you just have to look for the ones. Okay, so when you look for these ones and corresponding to that, you see what you have, and then you just add them up. And if you do that, then you can able to design the circuit. And the same you will do it for the carry out. Now let's do some quick questions. This combination logic circuit is described as, now previously what we saw is the let's go back here again. So we saw the logic diagram for full adder. So this is not actually the circuit it is representing here. There is some logic gates involved here. So let's see. Oops. So let's see. This is our circuit, and if you notice the circuit, this particular is your half adder. You remember we used XOR gate and AND gate. So this is one half adder, and this is one another half adder, XOR gate and AND gate, combination of that, and the output of the first half adder is going into the input of the XOR gate, and then carry out is basically combined together to the OR gate. Now you have to, so this circuit is basically your full adder. So that's what we see here. And then what are the sum and carry out outputs of this full adder? If you have 0 going in here, A is 0, B is 0, then the sum is going to be 0 and the carry out is going to be 0. Now if you have 0 0 1, so 0 0 and 1 going in here, so the sum is going to be 1 and carry is going to be 0. And if you have 1 0 1, so in this one you will have sum as 0 and carry out is going to be 1. So what are the sum for this combination? You will have sum as 1 and carry out as 1. Now next we have, so this is the answer. Now next we have 0 1 1. So again the sum is going to be 0, carry out is going to be 1. So you see that how different combinations of inputs can be added, and then you will get the sum and the carry, and this circuit represents your full adder. And then if you have any confusion, then you can just put up all these values for C and A and B, and then see what you get at the output of each logic gates, and verify if what we discussed is correct or not. So this is the end of the lecture. Thank you so much for watching.